Hello and welcome back. Unit 6, here we go. So we're talking about converse and the distance formula today. So in order to talk about the converse, we're going to think about something really quick. So is the triangle with side lengths 31, 21, and 20 a right triangle? Well, how can we prove that? Well, in order to find a missing triangle, we use good old Pythag, right? A squared plus b squared equals c squared. And this works every time for every right triangle. So if this is a right triangle, it'll work. So we got to use the Pythag to determine it. Now, we got to figure out which one's c. Obviously, largest side, got to be c. And then we can make the other two a and b. Those are interchangeable, right? So now we're going to plug in what we know. A squared, 21 squared, plus b squared, so 20 squared. Does that equal c squared, which is going to be 31 squared? So let's do some quick math. 21 squared is equal to 441. Plus 20 squared, which is equal to 400. And what is 31 squared? I got 961. So 441 plus 400 is 841. Does that equal 961? Not last I checked. So a squared plus b squared is not equal to c squared. Therefore, this is not a right triangle, right? And that's the converse. So let's go ahead and take some practice, right? So again, you're going to be able to determine if there is a right triangle, and then we're going to be able to find the distance between 2 points using the distance formula. So example 1, go ahead and see if we can figure this one out. Determine if the triangle with side lengths 13, 12, and 5 is a right triangle. Pause it, come back, see if you're right. All right, so 5, 12, and 13. Is this true? Well, if we remember our triples, I remember that 5, 12, 13 is a family. So I know for sure that this is, in fact, a right triangle. But if we don't remember our families, we're going to check it. C squared was going to be 13. 12 squared plus 5 squared. I get 169. 12 squared is 144. 5 squared is 25. 169 is still on this side. 144 plus 25 is in fact 169. So this is yes, right? So two different ways of proving it. Either it's in the family or a squared plus b squared equals c squared. If it's not a family, you have to check a squared plus b squared equals c squared because we don't know all of the families. So always check a squared plus b squared equals c squared to determine if it is in fact true. But if it is a family, we can say yes for sure. All right, so let's try another one. 12, 15, and 20. I'm going to go ahead and plug this into a squared plus b squared equals c squared. So again, 20 is going to be my largest side, so that's my c. Is that equal to 12 squared plus 15 squared? 20 squared is 400. 12 squared is 144. 15 squared is 225. So I have 400 over here, and 144 plus 225 is going to be 369, and last I checked, those are not equal, so this is no, not a right triangle. Okay, so again, you need to make sure that you're checking all avenues. If it's not a family, then we check a squared plus b squared equals c squared to determine if it is, in fact, a right triangle. All right, now we're going to do the distance formula. Some of you might have remembered seeing this in algebra, but if you haven't, here it is. So the distance formula is equal to the square root of x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared, right? The question is, where does this come from? Well, it comes from Pythagorean theorem, right? So think about that. If I make D equal to C, my hypotenuse, right? And then I make x sub 2 minus x sub 1 equal to A, and I make y sub 2 minus y sub 1 equal to B, then I'm simply solving for C, right? If I wanted to get C by itself, I would just take the square root of C to get it all by itself. So that's where the distance formula comes from, right? So you need to either be able to use this wonderful distance formula, which means we need to memorize it, right? So distance is equal to, and a lot of times you'll see it as the change in x all squared plus the change in y all squared, right? Or x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared. We're going to practice using this, but just to review, we always do PEMDAS, right? So you're going to do parentheses first. That P in PEMDAS stands for parentheses, or my dear Aunt Sally, or something. I can't remember how it goes. Anyway, please excuse my dear Aunt Sally. There it is. So parentheses first, so you're going to do your subtraction first, and then you're going to square it, right? So you get squared, and then you're going to do your subtraction first over here, and then you're going to square it, and then you're going to add these two numbers, and then you're going to take the square root. The reason why we square these things is so that we never, ever get a negative number. You cannot have a negative distance, all right? So let's practice using this. So if AB has coordinates A being 2, negative 3, and B, 5, negative 2, we want to find the distance between those 2 points. All right, so we know that this is going to be our x sub 1, and this is going to be y sub 1, and then this is going to be x sub 2, and this is going to be y sub 2. All right, x comma y, x comma y. So let's plug it into the distance formula. I'm going to do the change in x, so x sub 2 minus x sub 1, 5 minus 2, plus change in y, so negative 2 minus a negative 3, all squared. Okay, PEMDAS, remember, so 5 minus 2 is going to be 3, and we still have to square that, plus negative 2 minus a negative is going to make these both positive. So negative 2 plus 3 is going to give me 1 squared. So now I have 3 squared is going to give me 9. 1 squared is going to give me 1. So I get the square root of 10. And we can't break that down anymore, right? If I did 5 and 2, I can't break those pairs down anymore. So that is my final answer, square root of 10. We're going to leave it in radical form. I don't care what this is as a decimal. I want this answer, right? That's why we did a whole day of practicing with radicals. All right, let's take a look at another example here. So we're going to use the distance formula to solve for this line segment. So I'm going to show you 2 methods on this one because I have a graph now and it's wonderful with the second method. So the first method we'll use our distance formula because it's always good to review. So I'm going to call this x sub 1 and I'm going to call that one y sub 1. I'm going to call this one x sub 2 and I'm going to call this one y sub 2. Doesn't matter which one we make x sub 1 and x sub 2, you have to be consistent. So if these are both going to be 2's, those both better be 1's. If these are both going to be sub 2's, then these better be sub 1's. So let's go ahead and plug that into our formula. So we've got change in x, so x sub 2 is 2 minus x sub 1, so negative 3, all squared, plus change in y, so 6 minus 3, all squared. So let's just do PEMDAS, right? So negative 2 minus 3 is going to give me a positive 5 because a negative and a negative is a positive. And then 6 minus 3 is going to give me 3. Okay, and then I'm going to do 5 squared, which is 25, plus 3 squared, which is 9. And I get the square root of 34. I'm going to make sure that I can't factor that anymore. And I can't because 17 and 2 are both prime. So that is my final answer, square root of 34. And I'm not going to give me a decimal. You're going to leave it in the square root of 34. Radicals, that's what we want in our answers. Now I told you I was going to show you a different method, right? So the reason why we have this unit with distance formula is because it comes from Pythag. A squared plus b squared equals c squared. So if I just make that right triangle, right, so I just connected my horizontal and my vertical, so I drew a line down and then I drew a line across. I create a right triangle. There's a vertical line. I can count, right? If I go from 3 to 6, I'm going up 3. And if I go from -3 to +2, right, it's going to be 1, 2, 3, 4, 5. So now I have 5 and 3 for my missing lengths. I can now solve for my hypotenuse. So 3 squared plus 5 squared equals c squared. 9 plus 25 equals c squared. 9 plus 25 is 34 equals c squared. Get c by itself. Square root of c, 34. Same answer. Two different methods, same answer. So you can always draw a right triangle and solve for your hypotenuse because that is using the distance formula. Sometimes it's not as convenient to do this method because the points are just too far away. So using the distance formula is more ideal. But if you have a graph, go ahead. Use Pythag every time if you want. All right, so pause the video now, see if we got the distance formula down. And then come back, check your answer. So I'm going to use, we'll call this one x sub 1, y sub 1, oops, sorry, y sub 1. We'll call this one x sub 2 and y sub 2. Distance formula, right? So x sub 1 minus x sub 2 all squared plus -6 minus 1 all squared. 5 minus 5 is 0 squared. Plus -6 minus 1 is -7 all squared. All right, now we have to be really careful here. If you plug in -7 squared into your calculator, it will tell you the answer is -49. But negative times a negative is always a positive. So either put parentheses around it when you plug it into your calculator, or be smart and know that you'll always get a positive number in the radical. So you should always have a positive number in the radical. You will never get a negative number because if you try and take the square root of -49, it's going to tell you not possible in your calculator. Error, because that would be imaginary. So we can always know that this is positive. If it's negative, go back, check your math. You made a mistake. So square root of 49 is 7. Okay, so just keep practicing using the distance formula, and then we'll meet back in class and see how we're doing. Here's your ticket to leave. Go for it. Change in x, 8 minus 5 squared, plus change in y, -2 minus a -7 squared, 3 squared, plus 5 squared, gives me 9 plus 24, oh, sorry, 25, which means square root of 34. See you next time.